This is the 7th study session of MTH 102 General Mathematics 2 video lecture. We are going to be discussing about composite function and chain rule. Introduction. Composite function is the combination of functions in such a way that the output of one is going to be an input for the next function. In other words, it is application of function to the result of another function. We can say chain rule is a rule that can be used to solve derivatives of composite function. In this study session, you will be introduced to composite function and chain rule. When you have completed this study, you should be able to define the term composite function and solve problems that relates to composite function. Also, you should be able to apply chain rule in solving composite function problem. Composite function. Like we have defined earlier, that composite function is a function that uses the result of one function as an input for another function. Like you can see on your screen, when we have y equals f of x and z equals g of y, you plug functions of f of x into z. So you are going to have z equals g into bracket f of x. Composite functions f of x is denoted, like you can see on your screen, g using a symbol that looks like letter O, which means compose. F of x. So if you are going to pronounce this, you pronounce it as G compose f of x. Now let's solve an example so that you can understand what I just explained to you better. Now on your screen, the example there says if f of x equals 2x plus 3 and g of x equals minus x squared plus 5, find f compose g of x. As you can see from the screen, in order to solve this easily, you note the first expression that you have f compose g of x. That means wherever you see x in f of x, you plug it with functions of g of x. Now let's solve this. F of x is now going to be 2 into bracket minus x squared plus 5 plus 3. Then you have minus 2x squared plus 10 plus 3. And your final answer is going to be minus 2x squared plus 13. This will be our final answer. I hope you get what I just explained to you. You can see that it's very simple. Then let's solve another example. So given f of x equals x squared minus 4x and g of x equals x plus 2, what is f into g of x? Now from the example on your screen, just like we did in the first example, wherever you see x in f of x, you plug it with functions of g of x. So you are going to have f of x equals x plus 2 squared minus 4 into x plus 2. Now if you open this bracket, you are going to have x plus 2, x plus 2 minus 4x minus 8, which is going to give you x squared plus 2x plus 2x plus 4 minus 4x minus 8. Now remember, this is going to give us 4x, which is going to cancel out this, so that is gone. Then plus 4 minus 8, from here we are going to have minus 4. Then our final answer is going to be x squared minus 4. you can see that it's a very simple mathematical expression. Then the example we just finished is for function of a function. The example we are going to treat now is for function at a point. What do we mean when we say function at a point? That means we are considering the particular expression at a particular point. Now let's solve this example so that you can understand it better. Let's suppose f of x equals x squared and g of x equals 3x minus 2. Find g compose f of 2. Now how are we going to do this? First of all, we are considering g of x first, so you are going to plug the value of f of x into x in g of x. That's number one. After you have done that, then you equate the value of x to be 2. So you are going to have something like this. G of x is going to be 3 into x squared minus 2. And you recall that your x equals 2 from this place. So our g compose f of 2 is now going to be 3 into 2 squared minus 2. Then you are going to have 12 minus 2. And our final answer is going to be 10. Let's proceed. The next one we are going to be treating is for inverse function. What do we mean when we say inverse function? It means that you are going to invert the function in order to get its composite function. Now, let's solve this example so that you understand it better. So given f of x equals 2x minus 1 and g of x equals 1 over 2x plus 4. Find f inverse of x, g inverse of x, f compose g inverse of x, and g inverse compose f inverse of x. Well, as you are looking at this, it might look cumbersome, but no, it's not. Just follow the procedure we are going to show, and you will see that it's a very simple mathematical expression. Now, in order to find f inverse of x, that's the first one we are going to find. What you just need to do is, wherever you see f of x, represent it with y and make x the subject of the formula after you have represented it with y. Now let's solve for f of x. So given that f of x equals 2x minus 1. Recall that I said you should represent it with y. So you are going to have y equals 2x minus 1. Then you make x the subject of the formula. So you are going to have something like this. Y plus 1 equals 2x. And our x is now going to be 1 over 2 into y plus 1. Now, in order to get the inverse, you now replace your x to be f inverse of x and your y to be x into the expression we just got earlier. So if you do that, you are going to have your f inverse of x to be 1 over 2 into x plus 1. That is going to be our answer. I hope you understand the simple step I just took you through. Now let's proceed. Now, in order for us to calculate for g inverse of x, we are going to follow the same procedure. Recall that we say g of x is given as 1 over 2x plus 4. Now, if you are going to inverse this, just represent everywhere you see g of x to be y. So you are going to have y equals 1 over 2x plus 4. Then we make x the subject of the formula. So we are going to have y minus 4 equals 1 over 2x. In order to make x the subject of the formula, we have x equals 2 into y minus 4. Now, recall that I said the other time, if you are going to do this, in order to get the inverse function, wherever you see x, you represent it with the inverse of the function we are looking for, and wherever you see y, you represent it with x. So putting this into the expression we got earlier, we are going to have this g inverse equals 2 into x plus 4, rather minus is going to be minus 4. So this is going to give us finally the expression 2x minus 8. Now you can see these are simple basic steps in order to get your answer. Is nothing complex at all. Now let's proceed. Now, recall from what we have been doing so far. We said our f of x is giving us 2x minus 1, and our g of x is giving us 1 over 2x plus 4. We've been able to calculate our f inverse of x to be 1 over 2 into x plus 1, and we've been able to calculate our g inverse of x to be 2x minus 8. Now the next one we are going to be calculating is f compose g inverse of x. Now in order to calculate this, we first find f compose g of x, then we find its inverse, f compose g inverse of x. That's a simple procedure in order to do this. So let's get it started. In order to find this, we are going to plug g of x into f of x. So we are going to have, so our f compose g of x is now going to be, note this is not equal, but we are going to invert this value in order to get this. So f compose g of x is going to be g into 1 over 2x plus 4 minus 1. So we are going to have, x plus 8 minus 1. So our f compose g of x is going to be what? X plus 7. So it is this function that we are going to inverse. And recall, I said when you want to inverse, you just represent this with y, and you represent this, and you make this the subject of the formula, rather. Then you represent their value. That is how you are going to get the inverse function. So let's do this now. So now we have, note that we have gotten our f compose g of x also to be x plus 7. Now in order to find the inverse for this, we are going to say y equals x plus 7. Then you make x the subject of the formula, then you get x equals y minus 7. Then you represent it. So you have f compose g inverse of x to be x plus 7, rather minus to be x minus 7. This is going to be our inverse function for f compose g of x. Now the next one is to find g inverse compose f inverse of x. Don't be afraid, we are going to solve it one step after the other and you are going to see. What we just do here, we plug the inverse function of f into the inverse function of g of x and we are going to find our expression. Now let's get it started. Now recall that our f inverse is 1/2 into x plus 1 and our g inverse is 2x minus 8. So since we are going to find the value of g inverse compose f inverse of x, that means you plug the value, this value, into everywhere you see x here. So we are going to have 2 into 1/2x plus 1 minus 8. So we are going to have this, we cancel this, we have x plus 1 minus 8 and our answer is going to be x minus 7. That's for g inverse compose f inverse of x. Now recall that our f compose g inverse of x is also x minus 7 from our previous calculation. What we are just trying to establish here is just to let you know that g inverse compose f inverse of x has the same value as f compose g inverse of x, as you can see from our calculation. Let's proceed. Now we are going to be talking about chain rule. Chain rule is a method for finding the derivative of composite function or functions that are made by combining one or more functions together. Now let's solve this example so that you can understand it better. Example 5 says find the y dx, that's f prime of x, if f of x equals 3x squared plus x minus 2 all raised to power 8. In order to solve this expression, it's very simple. Let's do it like this. Let's this function represents u. So we are going to have f of u equals u raised to power 8. So what we are going to do now, we are going to find the derivative of this, that is du dx, and we are going to find the derivative of this, that is the f prime u du, and we are going to multiply the two together in order to find our answer. So the derivative of du dx is going to be 6x plus 5, and derivative of the f prime du is going to be 8 u raised to power 7. Then if we multiply these together, that is du dx multiplied by the f prime u du, we are going to find our answer, which is the f prime u dx, which you can see on your screen like this. You can solve this on yourself so that you see that what is on your screen is the correct answer. You can use it as a form of exercise. Now another example is for sine 2x. Said find f, that is derivative of x, if f of x equals sine 2x. In order to solve this also is a very simple procedure. Say let u equals 2x. Then our f of u is going to be sine u. Now derivative of u is going to be, that's u prime, is going to be 2, and derivative of f of u is going to be cos u. Then if you multiply derivative of u with derivative of f of u, you are going to get 2 cos u, and recall that u is 2x, then we have 2 cos 2x, which is going to be our answer. Now we have come to the end of this study, but before we go, let's do a quick summary of what we have been able to learn so far. We've been able to define a composite function as function whose value are found from given function by applying the result of one as an input to another function. We have seen how it can be denoted, and we have seen how we can solve composite functions of function, composite function at a point, and that of an inverse function. We have also seen how we can use chain rule to solve composite function problem. We have come to the end of this study session. You can read through your study part to complement your knowledge about the subjects discussed in this video lecture. Thank you for listening. See you in the next class.